Hello and welcome to the session. In the last session, we had discussed about the basic concepts of programming language, where we discussed basic elements of programming language like variables, constants, expressions, and so on and so forth. In this session today, we'll be discussing about something like looping and decision and assembler, compiler, and we'll just introduce them, assembler, compiler, and interpreter and their role. And we'll also discuss a little bit about algorithm and flowchart also, but we'll be using them in and how do we write algorithms, how can we solve problems with the help of flowchart and algorithms, and how we can convert that into a programming language. Well, if you remember, last time we have discussed about the concept of decision, right? Where the decision basically is a concept where we take a decision, and that decision is with the help of an expression. If the expression is true, we take one decision. If expression is false, we take another. So this is the kind of thing which is there in the programming language, and the condition, normally the keyword which we use is if, okay, and the expression, Boolean expression, is enclosed in a parenthesis, okay, and what you see here is an operator, okay, and %2 basically is a remainder operator, and what this is basically a relational operator which compares it to 0. That is, on dividing the number n, which may contain any value between, let's say, suppose it contains 21, then n will, this will contain, the remainder will be 1, and then we will be able to get to, this remainder will be 1 and it is not going to be equal to 0. But if it is, suppose the n is 20, then the remainder is 0, then the condition true is met. In that particular case, the printf statement that the number is even will be printed. Otherwise, if it is not true, if it is false, then the else condition will be done, and this particular if statement is very common when we use or when we do the programming language. But in addition to else, there is very important concept, and that is called the looping construct. Now, the looping construct goes like, over here you might do some initialization, right? So you may initialize the values in this particular zone. Then you take a test of condition, all right? And condition will have only two ways. One is true, okay? So in that particular case, it goes and performs. So if the test condition, if it is met, that means the condition is true, then you go to this particular green box, right, and repeat this, whatever things has been mentioned here, they are performed, and thereafter, once it is completed, the test is taken again, all right, and once again true, or once again this particular thing will be performed. So a particular sequence of operation may be repeated. This may be required when you want to add a series of number, right? So you want to repeat it, and once the numbers are over, then the condition, for example, number is over. Suppose you wanted to check, add 10 numbers, so it is 11th now, the iteration is 11, then it becomes false and you come out of the loop. And then you perform certain operations thereafter, okay, in consecutive. So this is the way the looping construct work in a programming language. All right, and looping construct is one of the most important construct in addition to the conditional operation. Obviously, operators are playing the most important role in both the cases. Well, there are variants of looping statements in programming languages. For loop is one, which basically checks the condition, initialization and checking the condition in the beginning, while also does the same thing. And do while basically checks the condition towards the end. These three loops are most important loops when we are dealing with programming languages. Let us try to understand this with the help of an algorithm, and that algorithm when it leads to a program. Well, the algorithm and flowchart which we have made is to find the product of first n natural numbers. What does it mean? That suppose I need to multiply 1 into 2 into 3 into 4 like that. Okay, till n. So if I want to multiply n natural numbers, how I am going to perform this? Well, always there is a start. That is what is visible over here. Okay, in the next step we are inputting number n. Obviously n should be defined, right? What should be the value of n? So this particular box, okay, this is a parallelogram which basically defines the input, right? So over here you are giving the input, then you are doing initialization. So product is initialized to be 1. So that particular operation is going to be here, and counter is going to be initialized to 1. Even that counter initialization is being performed into this particular step. So I is a variable which is initialized as a counter variable. The name, it is quite common that I, j, k are used as counters. So you initialize I to 1. And then counter, that is the product, also as 1 in this particular processing box. And in the next box, then you will be checking. All right. So compute product equals to product into I. So here you are just computing the value of product is equal to product into I. Okay, so initially product was 1. So when the value of I, we are starting from 1, and the value of I will be checked till n. So 1 into 1 will become 1. Okay, then at the next step you increment I. So at this place in the first iteration I will become 2, and then you are checking. So this is a loop where do while is coming later, where we are basically checking if the counter is less than equals to n. If yes, then you go back, otherwise you simply truncate. Okay, yes, you just print the output and result. So obviously suppose n is 5, then it will go back because the value of I is just 2, and that is less than n. Okay, less than equals to n. So you go back, you perform it. So now 1 into 1, now 2 will be multiplied into it, right? So it becomes 2. Okay, then I will be incremented to 3. Once again the check is there, I is still less. So 3 will be multiplied, 1 into 2. So it will go on. It will be multiplied by 4 and then 5. And once the complete result is there in the product, then it comes out. So this is how the looping works, and this is how this particular algorithm as well as the program works. But how to write the code for it? Well, when we write code for it, as we discussed, so we basically what we are doing is include stdio.h, that is standard input output. Those standard input output basically are the files, in fact the header files which contains the basic declarations of the functions like scanf and the printf, as we discussed last time, right? And main is the main function where all the processing is going to be done. All right, so we are defining n and I as integer values, and product we are initializing. In addition to being an integer, the product is 1. Then we print that enter number n, and then once you print that, this will be displayed on the screen. So user, when he or she runs the program, the value whatever is entered by him or her will be scanned to this n value. This is the syntax. Ampersand is basically an address of variable n. Okay, so which right now you need not know about, but then this is how it works. And then here is the for loop. Instead of while loop, we are working with the for loop in this particular case. I is initialized to 1, I is less than equals to n. We are saying I plus plus, and we are simply saying product equals to product into I, which will be repeated many times till I is less than equals to n. The incrementation, so initialization, checking, then this particular incrementation is going to take place once this particular thing is performed, then incrementation, and then checking again. Then incrementation and performing this particular step later on, and then checking again. Then once again performing the step, incrementation and checking again. So like that it works. All right. And finally, when you come out of this particular while loop, you will be printing the value of this particular natural number. So printf and scanf are the functions which basically are part of standard input output H. So this is how a C program basically works, or C program is written, and this is the typical looping construct as far as C program is concerned. How it works once again: initialization, I equals to 1 is the initialization, then checking the condition whether I is less than equals to n or not. If it is less than equals to n, then the product part is done. And once the product part is done, then the incrementation part is done. I plus plus is simply increment I by 1. That is what it means in C. Okay. And this whole loop will be repeated till it is less than I is less than equals to 5. Suppose the value of n is 5, right? N is 5, then this particular loop will be executed at least 5 times. All right. And it will be multiplying the value into the product which was initialized to 1. Remember, when you are multiplying, you are initializing to 1. Otherwise, this will become 0 and the product will always remain to be 0. And one more caution here is that ultimately these are fixed point numbers. Integers are basically having a size in computer, right? So what you will find once you start multiplying with larger numbers, suppose you compute n with the value of, let's say, 200 or 300, then you will not get the correct result, because the size of the number which has been produced is going to be more than the allowable size of the integer. So that kind of problem basically are called overflows. So these kinds of problems can be checked. You can change the data types and so on and so forth. But right now those things are beyond your scope. At least you should know about that these kinds of things are there when we are dealing with numbers or programming in a sense. Well, in addition to other things, there is another element of programming language which is very, very important when we go on for programming. It is basically a set of elements of same data types that can be individually referenced by an index. Okay, so one single name and you are able to access many variables with the help of an index, and the arrays can be one dimensional, two dimensional, and they can even be multi-dimensional. But what is the purpose of arrays? The purpose of arrays is, suppose you want to store marks of 20 different variable, 20 different students of a class. Will you be requiring one variable to store it, or will you require 20 different variables? If you require 20 different variables, it's going to be very cumbersome program. So if we can have same name and then we can put an index over there. So in like marks 1 in bracket. So marks 1 belong to one student, marks 2 belong to second student. Like that, if we can do this particular operation, then this array comes in, right? So as far as array is concerned, let's once again understand this with the help of another problem. And the problem basically says to find the sum and average of marks obtained by 20 students in some subject of a course. So it starts with, once again, the start is the starting point. Input marks of 20 students, that is, now this is basically array, where S is the name of the array, okay, and 20 is basically the number of or the indexes which are possible. So marks of 20 students are being stored into this particular array, and by default C stores these indexes as 0, 1 till 19. So instead of storing them as 1 to 20, it will be stored as 0 till 19, which is one and the same thing. All right. Okay. So how this particular thing is going to work, or how this program is going to work, once again we are following the same convention where we are checking the condition is over here, but it could be over at this level also. Okay. So then at step 3 we are initializing sum and counter to 0. Whenever you are summing up things, then you always start with the initialized value of 0. Whereas in product you initialize with the value 1, because you are multiplying, right? So 1 into 2, 1 into 3, 1 into 4, right? Otherwise, if you initialize with 0, the multiplication is always, result is always going to be 0. Whereas in sum, if you add 0 with anybody, nothing is there. So you add 1, 2 and so on and so forth in it. Okay, so you want to sum them up. Okay, and counter equals to 0. So this is what you have stated over there. And then this is a very important statement. So we have used a variable counter and we have initialized to 0. So what we have stated, sum equals to sum plus S, which is consisting of 20 values starting from 0 till 19. So S0 will be added first. That means the marks of the first students, right? That will be added to it. Then increment the counter, that is counter becomes 1. Then and we check whether counter is less than 20. If yes, go to step 5. So we simply roll back over here. We keep repeating this particular step. And what you see in this particular case is once counter becomes 2, then the marks of the second student, right? The counter becomes 1. So initially it was 0, it will become 1. So S0, then S1, then S2, then S3. Okay, like that, all the marks of the students will be added to this sum, basically one by one. And that is how the looping works. So you are adding the step one by one. This is what looping is all about. So you repeat this particular things one by one. Okay, and that is how you work in general also, isn't it? Suppose I give you marks of 20 students. This is what exactly you will be doing. First you will add the second student, first student, take the first student mark, then add the second, then add the third student mark. Now they are being represented in computer as S0, S1, and remember 0 is in parenthesis, right? The big parenthesis. So that is how it is basically representing the array, right? So first student become S0, S1, same name but changing the index, and that facilitates programming because using the value counter and just changing the value of counter, you will be able to access all the elements of the array. All right. So we are just checking here, and once you have computed the sum and you have reached to a stage where you have added all the student marks, that is basically by checking counter is less than 20 because the highest index is 19. So when index becomes or the counter becomes 20, that is the time you terminate this particular loop and you come out from here. All right. And what you will do in this particular case, you will print sum and average. So you have already got sum and compute the average. How will you compute average? Because sum divided, since you have 20 students, so you simply divided it by 20, although you could have divided it by n also because n is the number which you basically started with. Okay, and over here the marks of 20 students, here you say n equals to 20 and you can use that kind of a representation, and thereafter finally you print sum and average, and that is the end of the program. So this is the way the algorithm works. But how my program is going to be in this particular case? Well, we once again start with input output. All right. Okay. And the main program starts here. So this is standard input output.h. That is the header file containing all the declarations of the functions. Now in this particular case, integer s is declared to be integer consisting of 20 possible integers, right? So, and their indexes are going to be 0 to 19. So, S0, S1 till S19. So, they form the integer value. Then comes the float. Float is basically the real number, as I told you last time. So, average is float because average is going to be slightly, average is going to be a value which is not going to be integer value. It may be having some decimals also, and some since may be integer, so but still you can count it to be as float, no problem on that. Then printf once again will print this onto the screen that enter the marks of 20 students, and here is the loop for reading. Okay, so you said that print the marks of 20 students, and then you are starting with the value of I equals to 1 till I is less than 20, I plus plus. So what is going to print? 0. It is going, I is 0. So it is going to print 0, right? 0, and then over here, what you will do? You will read the value. Okay, you will print actually I plus 1. So you will print when the value of I is 0, it will be print 1, that is enter the marks of first student, so that you don't get confused among the indexes, right? After all, the person who is inputting the data may not be the person who is programming it, okay? So for him 0 does not matter, but what we are asking, print, that is enter the mark of 20 student, and here we are saying 1. So 19 will be displayed as 20, and then you will be scanning it, but you will be putting it in S0. All right, and for the 20th student you will be putting it in S19. So that is how the C program is going to input the values. But after the input, something else is to be done. We need to find the sum and average. So how we are going to do that? So this is just continued from the previous page. So we reinitialize I to 0. We will be reusing I once that particular loop is over. I is free and we can reuse it. So I is reinitialized to 0. And while I is less than 20, right, that means 0 till 19, sum equals to sum plus Si. So first it will be added S0, right, then I will be incremented, same as for loop, okay. Then I becomes 1, sum 1, then I becomes 2, that is sum equals to sum plus 2. So sum is basically getting all the values. Initially, first iteration it will get S0, next iteration it will get S1, third iteration it will get S2, S3, S4 till S19. When S becomes 19, at that point of time I becomes 20. That is where this while loop is going to terminate, right, because I now is no longer less than 20. It is 20, right? So this particular condition makes sure that loop terminates and you fall through this particular statement. You can come out of while loop, and that is where the average is going to be computed, and this is where you can print the average as well as sum. So this is how the C program, as far as writing C program is concerned, as far as with looping and all those kinds of constructs, looping as well as using arrays are concerned. Now, there is another concept in programming language, which is basically the interpreter. After all, you have written your program in C language, but how it is going to be converted into machine language, right? So for that, you need tools. So the first tool, which is editor, is primarily used for input of the program. Right. So it is an interface that is used to write your program. So this is where you will write the C program as we have just developed, right? Then comes the assembler. Assembler actually is not the one which is going to be used here. Assembler is for assembly language programming. So let's drop that for the time being. But then there are interpreter and compilers. Now interpreter and compilers are basically tools which converts program written in a higher level programming language like C into machine language. So when you want to run a C program, what you require is a compiler or interpreter of C language into the related machine language. So that is where the whole thing works. Okay. And assembler converts program written in assembly language into machine language. You may not encounter this kind of a thing in general, but you will be looking forward to assembler when you go to higher classes or so. Okay. And this diagram basically explains that whenever there is an editor, there is a source program associated that you do go for compiler or interpreter, and that produces an executable program which can be run, which is in machine language and can be run onto the machine. Assembler does the same thing. Okay, assembly language program goes through assembler and machine language program is produced, and this is how both the things work. So let us try to summarize what we have covered today. Well, in the previous sessions, or in fact today and last time, that elements of programming language and algorithms, that is what we had discussed in the previous class, and a little bit about flowchart. However, in this session we have discussed sample programs with loops and arrays. These two are very important concepts when you deal with any programming language. We have also very briefly discussed the concept of editors and translator in programming language, which are very much required when we are dealing with programming language. So with this knowledge of programming language, you can actually start programming if you if you know little bit about algorithm. If you can start designing the algorithms, and gradually you can move towards the programming language implementation and so on. With this, we end this particular session. Thanks for being with us.